x is equal to x sub I minus x bar divided by s sub x. How many got that? Just to get an idea, it looks like just about everybody. If you haven't memorized the equations, by all means do so. Don't wait till later to do it. The correlation coefficient is the sum from I equals 1 to n of z sub x sub I times z sub y sub I. Actually, that looks like an x. Z sub y sub I divided by n. So it's the average product of the z-scores. Then you're asked to compute the correlation coefficient, in this case over here. So here's one where the mean was 2 and the standard deviation 1, and the mean here was 30 and standard deviation 10. If you hadn't been given these, you know how to do that. You can find the mean by adding them all up and divided by n. You can find the variance by subtracting the mean and squaring it and summing it up and dividing by n. You can find the standard deviation by taking the square root of that. And then we find the z-scores. So z sub x sub I is going to be equal to x sub I divided by x bar, which is 2, divided by 1. That'll give us our z-scores. So 0 minus 2 divided by 1 is negative 2. And I put the x's in order here just to speed the world up. 1 minus 2 is negative 1 divided by 1 is negative 1. So negative 1. Any questions about the z-scores for the x's? Okay, 2 minus 2 is 0. 3 minus 2 is 1 divided by 1 is positive 1. And 4 minus 2 divided by 1 is 2. So those are the z-scores for the x's. And their z-scores, so they'll add up to 0, and they'll have a mean of 0, and they'll have a standard deviation of 1. And then we find the z-scores for the y. And the mean of y was given to you as 30, and the standard deviation 10. So we're going to take 50. So the z-score for y is the same formula, except we substitute in y instead of x. So we take y sub I minus y bar divided by s sub y. So that's 50 minus 30 divided by 10 is positive 2. And 40 minus 30 divided by 10 is plus 1. 30 minus 30 is 0. 40 minus 30 is 10 divided by 10 is plus 1. And 30 minus 30 is 0. 20 minus 30 is negative 10 divided by 10 is negative 1. 30 minus 30 is 0. The 20 is minus 1, and 10 minus 30 is negative 20 divided by 10 is negative 2. Any questions about the z-scores for the y's? So we need to find the z-scores, then we multiply them together. So z sub x sub I times z sub y sub I. And in this case, we see the small numbers of x go with the big numbers of y, and the large numbers of x, 3 and 4, are relatively large for x values. They go with the small values of y. So our products are coming out negative in this case. So minus 2 times 2 is negative 4. Minus 1 times 1 is negative 1. Negative 1. Negative 1 times 0 is 0. 0 times positive 1 is 0. 0 times negative 1 is 0. 1 times 0 is 0. 1 times negative 1 is negative 1, negative 1, and negative 4. And now we need to add up the products of the z-scores and divide by 14, because n is 14. And so we have 4, 5, 6, and 6 more makes negative 12. So our correlation coefficient is negative 12 divided by 14. Negative 12 divided by 14, that's negative 6 divided by 7ths, and that's about minus 0.86. All right, how many got that? All right, questions about it? What did you need to know in order to do it? You needed to know the equation for the correlation coefficient. You needed to know how to find the z-scores and how to multiply them and how to add it up and divide by n. Any questions about how to do it? I didn't see a whole lot of hands raised that time. Questions? So you haven't memorized this equation yet, by all means do so, because we're using it right now in this part of the class. Is negative 0.86, well, let's draw a scatter plot. Maybe the scatter plot could have told you approximately what this correlation would have been. So we've got 50, 40, 30, 20, 10. 0, 1, 2, 3, 4. So here's our xi, here's our yi. And corresponding to 0, we have a 50. So we put a point in there. And then there are 3 ones. They go with 40, 40, 40, and a 30. And then there's a whole lot of 2s. There's 140 and 120, and the rest are 30s. So 120, 140, and 4. So I sort of don't overlap them so that I can count them up later. Then with the 3s, we've got 2 20s and a 30. Corresponding to the 3, we've got 2 20s and a 30. And corresponding to the 4, we have a 10. Any question about how to draw the scatter plot? How many got the scatter plot here? Okay, remember, you don't have to worry about raising your hand in here. We're able to do the homework. So the homework, remember I advised you, if you haven't done it, by all means do the homework. Print out it works better if you print out the sheet that's from the page from the handout or course materials. Then if you try to look at just the titanium, the display of the numbers, it just lists them out, so you have to set up the table. And so in the course materials, this page is set up for you with the columns there so that you can do it easier. So if you haven't done that, by all means do that. Any questions about how to draw a scatter plot? What's the sign of this correlation just looking at the scatter plot? You should be able to see that the big numbers go with small and the small numbers go with big, and this is a negative correlation, negative 0.86. Well, is negative 0.86 a big correlation, a strong correlation? How do you find out again? How do you find out if a correlation is a strong correlation? What's the rule? You square it. 0.86, negative 0.86 squared is about positive. Well, it's always going to be positive. If it's, here's our little table of correlation and r squared. So 0 squared is 0, minus 0.1 or 0.1. Negative 0.1 squared is also 0.01, and positive 0.1 squared is 0.01. And now we're down here at about negative 0.86, where positive 0.86 squared is going to be about 0.74 or so, almost 75% of the variance. Would you go to the mall if you had 75% off, 74% off today? People are nodding yes. Remember the story about the kid with the telegram and the cameras aimed at your door? And today for you only, everything is 4% off. That's a 0.2 correlation. Minus 0.2 or 0.2 correlation corresponds to 4% off. So if you're not impressed by 4% off, then you shouldn't be impressed by a 0.2 correlation, even if it's statistically significant. 0.3 or negative 0.3 correlation would be 9% off. 0.5 or negative 0.5. Now, what does this example represent? Well, X is the number of absences, and Y is the score on a final exam in somebody's class. Is that a pretty strong relationship? Yeah, it is. Calit reports this in Chapter 2 of Calit. So you've read Chapter 2, you've seen the graph showing the relationship between the number of times the student was absent and the score on the final exam, and he reports it as something in this neighborhood. Well, we'll take a look at exactly what his graph represents. Any questions about how to calculate the correlation coefficient? Now we're going to need the correlation to make a prediction. So remember, how well would you do in this case at predicting if you didn't know anything except the mean? What would you predict if you're playing the variance game? What's the variance game? You're going to be guessing these numbers, trying to predict these numbers. Some of you are interested in predicting your final exam score. You can use your midterm exam to help predict it, plus this relationship. So number of absences plus your score helps you, but you need to use multiple regression, and this one needs a negative weight. The higher the number of absences, the lower the grade. The fewer the absences, the higher the grade. All right? So if you knew nothing, what would you guess? So if you would guess the mean, if you were trying to predict this score here, maybe this is the final exam. You're trying to predict somebody's final exam score. And if you knew nothing, what would you guess? You'd guess 30. And what would your average squared mistake be? Well, the square root of the average squared mistake is 10, so that means the average squared mistake is 100, because the variance of these numbers is 100. The standard deviation is 10, the variance is 100. So it costs you $100 on average to predict somebody's final exam. You could put it this way. Maybe they said, I'll bet you $100 you can't predict my exam score. And you said, yes, I can. I predict it's going to be 30. On average, it would cost you $100, right? So he's going to charge you according to your average squared mistake. If you're just predicting people's exam scores, it's going to cost you $100. So if you're right, maybe they give you $100. That's an even bet. But you can do better than that if you know how many absences there are. How much better can you do? Well, you've got a correlation of negative 0.86. That means you get 74% off. How much does that mean it's going to cost? Well, if you get 74% off, how much is it going to cost? If in general, if you get r squared off, it means you still pay 1 minus r squared xy times the original variance. So this is the variance of the residuals. It's called s squared y minus y hat, and it's equal to 1 minus r squared xy times the variance, the original variance. And if our original variance was 100, then we get 1 minus 0.86 squared. That's 1 minus 74%. That's 26%, so it's 0.26 times 100. So if something was going to cost you $100 at the mall today and you get 74% off, how much is it going to cost? 0.26 times 100, or $26, because you get $74 off. So this is the equation for that. This is what it cost before. This is the equation with the discount. What does this equation represent? It represents the variance, y minus y hat. So y hat sub I is the predicted value of y based on x. So it's the predicted value of y sub I based on x. If you knew nothing, your y hats are always going to be y bar. But in this case, you're going to make a prediction based on x. And I'm going to tell you how to do that in just a second. How to make your prediction. And if you do your prediction according to the right formula, what's the average squared mistake going to be? It's going to be only this. And what's another equation for the squared mistake? That's each score, yi minus y hat I, quantity squared, I equals 1 to n divided by n. It's the average squared mistake. So it's just like the formula for the variance, except where you make a prediction of y based on x instead of your prediction being the mean. If you put the mean in here, that's called the variance. If you put your prediction in there, it's called the variance of the residuals. And the square root of that, sy minus y hat, is equal to the square root of the variance of the residuals, y minus y. So this is called the error of regression. This is sometimes called the standard error of regression. This formula right here, and this one's called the variance of the errors of regression. And another term that they use in business, some of you might be business or econ majors, the term that they use in business and econ is they like the word residual. Residual is what's left after you predict something, it's what's left over. So sometimes you'll see the word residuals instead of errors. People in business and econ like to use the term residuals. They may use it in some other branches of statistics as well. All right. Any questions about that? So I'm going to show you how to use that formula a little bit later. You can restart the tape here, so I'm going to start another little